Hello and welcome everybody. Hello. This has been going on probably a little while. Right, how is everybody doing this evening? It's a wonderful day today. It is the day of our Lord Odin, Odin's Day, Wednesday, of course. And today we're actually going to be doing something slightly different. Today we are going to be working again on my new little language, which is outputs directly to WASM. So the entire language has been designed around the concept of WASM and it's also its ideas. I pretty much designed the syntax already, so I don't need to worry about that. I'm just finishing off the parser as I got it's nearly done. The parser is actually, so the language is pretty simple, but it's not the thing is, this language is not basic. It's not a toy language. This language will have a lot of features in it that many languages don't even have. So it'll actually be a very, very useful language to have, is what I'm trying to state. So we can probably get along as we're going with it in a minute. So people can follow along. I wrote a little thing here on Gist, on the gist, or whatever, GitHub's gist, whatever thing, about my little idea for the language, and it's going to be explicitly for the WASM platforms, the WebAssembly platform. Yeah, so this is where kind of things are. So that's what I'm designing it for. So that means I'm designing around the features that WASM has, and I'm not designing to be extremely generic for other platforms. Theoretically, in the future, we could easily get Odin working on WASM. In fact, it's probably already possible now. We just need to support the core library to have like a WASM backend. But at the moment, I'm just trying to have a little toy language myself. So this language is going to have quite a different declaration syntax to Odin, but it's going to be different. Again, this. Am I planning on maintaining both Odin and Midgard? Odin, yes, definitely. Midgard, yeah, maybe. But again, I'm going to probably release this soon. Not yet. I've not even actually started a Git repo or anything for this yet. It's literally just as I go along at the moment. And I'm just trying to make sure this makes sense for me. So the more I go through this, the more it should feel okay. That's kind of the general gist of everything. So the entire thing is going to be kind of properly correct. So it's not an exercise for me. It's just I want a little of an experiment. It's more like a little test bed, and I was just to get away from Odin for a little bit as well and other projects. Just something different. So the idea here is just a nice little language, nothing too complicated, but every single construct that's in WASM is kind of very easily expressed in this language. So that's one thing to put very cleanly. So for instance, you've got like imports, you can import different files. This is not in WASM, but this is something, again, you want a package module system with everything. Unlike Odin, we don't need the package directive at the top, and this is because we don't need a stable ABI. Because we're only going to have stable ABI names for things that are explicitly exported. And that's all we're going to ever care about. Everything else, their names doesn't make a difference. We just can mangle them, but it makes a lot of sense for WASM. It may be okay for more when you're developing things, but nothing other than that. We've got constants here, which are kind of similar to Odin's compile time constants, which are only known at compile time. Again, something to go. We have variables. These are, again, just like variables, simple enough. We have type declarations, similar to Odin. These are distinct by default. If you put an equal sign there, then there'll be an alias. So it'll be more like, hey, this is like a constant. So theoretically, I could merge this with the thing, but I think it's clearer to keep them, hey, this is a type declaration. Just keep them clear. You can with this prefix declaration syntax. Here, I'm not sure if I could need to have the arrow anymore. I like it aesthetically, but you don't need it if I'm not doing colons here. If I'm doing it very minimal amount of syntax, then this is all that I need. I'm also going to allow for foreign blocks, so environments and stuff in WASM stuff, you're going to have the environment stuff here, and then you can say what is foreign. Pretty simple. And because of this syntax, you don't have to have the triple dash or triple hyphen like in Odin, because this again the qualifier focus syntax, which is the name for my prefix stuff, allows you to declare stuff like that very easily. I'm also allowing like group declarations like Pascal, but with parentheses here, just so you can group them all like that, and it looks all lovely jubbly. It means you can do a lot of cool stuff. We're going to have some basic data types in here. These are probably going to be optional, which I wrote down here for the time being. I just want to get the basic ones first. So basics are just integers, floats, Boolean strings, and like characters as well. Pointers, arrays, and slices. Structs and enums. And there's just structs and procs, to be honest with you. The integer types, yep. The pointer types, the array types, slice types, yep, that's all fine. So I can probably edit this to make it a bit clearer, actually. I'm not getting the type int in this like in Odin. I'm going to have its I size and U size, and the main reason for that is I don't have to have a uint pointer anymore. And it's, even though in Odin I make the distinction, in this language I'm not going to for a lot of reasons, because it's such a different environment, so you can have different things going on. And then again, basic control structures, if, for, switch, defer. I'm doing the same thing that Odin Go does, which is mix all the while loops, all the different loops into for. I'm going to break, continue, and fall through. That's about it. So if anyone's got any questions, please just ask. I've just been talking quite non-stop now for the past few minutes. Okay, so everything's honky-dory. Okay, so you probably won't be able to get the gist, but it's on my whatever, mine there. I'll make a little just edit here while I'm here, but now I'm not actually... Ooh, not in my GitHub. I'm on an incognito page because I was. So we can. I just want to change the type stuff here because it's a little bit confusing. So we don't want bit sets in that list. We just want the basic stuff there. Yeah, update secret guest. That's perfect. This is not a drunk stream. If it's a drunk stream, I usually label it as a drunk stream, but no, I am sober today. For now. You never know what happens when you go into the stream later on. You never know. I'm just drinking water at the moment, but no. So today is all very sober, so if you want to ask me some serious questions, I'll be able to answer them. So, I've been working on a new parser. This parser already is 1,500 lines long, and that's not including the ASTs, which is like 300. But in general, the entire language, I'm going to probably aim to keep it under 10,000 lines is my goal. I probably may have to go to probably a bit more, but 10,000 lines of Odin code, excluding whitespace, I think that's doable. For instance, token file, it's 250 for tokens, and the tokenizer is 600. Again, there's a lot of whitespace in there as well. But that's full on to everything that's done. So what is the reason behind this? So the reason behind Midgard is I wanted to actually experiment with the WASM, which is the new WebAssembly stuff, and see how it was like. I wanted to more focus on a certain very particular platform, and this language is only ever going to be working for this platform and nothing else. So the idea behind this language is that I can actually make it tailored for the web. So one of the kind of things I hate about the web, and many people do as well, is that the web was not designed for, anything really. It's not designed very well for anything. And what I mean by that is HTML, CSS, and JavaScript are all crap. So HTML, of the bunch, HTML is probably the best. HTML is fine, it's just a markup language, but it's still not great. I'm like... The style that they did is just prone to have errors in it anyway, so it's like, great, that's just not great syntax. The other thing is, what was I thinking? Yeah, the other stuff is JavaScript is okay, but it's, oh god, as if most people know, JavaScript has got so many flaws to it, and it is a buggy language in the fact that the language has got kind of bugs in it, but they've got to keep them there. And then CSS is the worst bit. The general idea is that they wanted to separate presentation and content, so that you could easily swap out the style sheet and have it work for anything. So the content was just basic then. You just put styling for the content. Now, if you told a graphic designer, they'll just look at you and go, what? Because they'll be like, but the presentation is content. And there's the problem. If you try and that idea of trying to separate it makes no sense. And this the whoever when they designed it, they're absolutely idiots. And they did not talk to any graphic designers or typologists, not typographers, not typologists, different thing entirely, typographers and stuff like that. They just completely ignored them and went, yeah, whatever. So in my opinion, that's just like they just didn't do anything. So WASM seems to be a way for now for anyone to use any other language now other than the other tool set. Maybe with some glue code of the other three, of course, but pretty much I can get around it all now. So my idea is to use probably either something like the canvas, or at least just have literally even WebGL might be good enough. And then plus a lot of other things to help the accessibility things, because you'll need them just like, oh, screen readers need to be able to read something, or stuff like that. Or like, oh, you want to have a hover over this is an image and you want to do stuff what you need to. But if I can just pretty much get a big, to even begin with, have a big screen of pixels, and I can write a pixel to the screen like that, that is extremely good already. So in the previous two streams, so I'm going to stop now for a second. For the previous two streams on WASM, I actually created a full working assembler. And this assembler for WASM is 1,000 lines long, and that's the entire specification written in Odin. And it's pretty much fully featured. A lot of it is just defining the structures, and then the rest is just some helper functions. But in pretty much, this is it. And that is pretty much writing all the different sections. It's pretty nice and useful. So yeah, so it's a bit, so in against this idea I want to make for Midgard, which I'm calling it, because I wanted a middle ground of a language. I wanted a middle ground that was something like C was to assembly, something that was a direct reflection of what WASM was capable of, but also, I'm trying to think of another way of putting it, not just a middle ground, but it's also a middle ground between the user and just don't have to deal with that crap. So it was just, I didn't even think of the name Midgard. I thought, oh, Midgard makes perfect sense. Middle Earth, middle ground, perfect. So just put them together. Like so. So now that that's all out of the way, we can actually start finishing off the parser. So I've been working in the parser in my kind of little spare time. It's only spent a few hours on this. But in general, I am parsing this source code here and it's all working. So I've been making sure everything works correctly first. Not everything is finished yet. For instance, procedure types aren't parsing correctly yet. So we've got proc decal, but then we need to actually parse everything else here. So simple expressions. So parse expression. We have many other different things here. So this would be, I need to get I think it's procedure literals I now need to look for. So if I did this, it's going to go crash at me and say, oh, whoops, I didn't actually, that's one thing I just realized I didn't do correctly here, was, what did I do wrong? When I do the error function, token error, so what I'm going to do is I'm going to use the new kind of style, full path, like the Python style of stuff which I added, which was very simple to add actually, didn't take long at all, but yeah. Expected an operand, and I got something else, so it's in the operand code. Oh, isn't it lovely? I forgot all about that. And yes, look, I haven't done this. There's a big to-do for writing the operand. And we can now expect token proc, and then we want to get the signature. So we have proc signature here, params result. There's the signature code for it. Now, on its own, it would be a type. Now, if the next thing was a body, so I'm trying to look for a func proc, or whatever, procedure, literal in a sense. But you want to kind of check for both, in a sense. If that makes any sense. Hello, hello, hello. So I think actually to clean things up slightly, I might just return this as parse proc type, or lit, because that was lit, man. And okay, we can do this. Parse proc type or lit parser st expression, like so. And then we can then check to see if there's a body or not. So we can check doing this. And then I think what I want to do is parse proc type as well. And that can go into here. Makes sense? Now, if we can check to see the current token kind, and it's not an open brace, then we know it was the type. Else, we now want to look for a body. And what I'm going to do here is I've got the expression level stuff, like so, body, parse, body. That was easy enough. And now we've got the literals. So we're just going to call this lit, put a new node in there, st proc literal. Lit. I'm going to put the position information in there, and body, and lit, proc literal, so we have a type and body. I was very clever when I did this. By the way, this pos and end stuff is so that you know how the position of the token and the end of the actual list, so you can actually just say, hey, if you were doing fancy errors, not in the parser, but fancy errors where you literally have got now the bounds very easily. Return lit. That's fine. Now, it's going to crash that. I haven't handled this bit here, of course, but that's fine. Hello, hello, more people. Welcome to the stream. How's everybody doing? So now I'm just going to do here the type. So new node. st proc type. Pos is token pos. Proc type. End, it could be results. No, results could be end here. If results doesn't equal nil, else it's params.end. Yep. Type.top is token. Oops. Params is params. And results is results. Return type. Odin is not going to be abandoned for Midgard by any stretch of the imagination. This is going to be such a not lit list thing ever. Still failing to parse, but that's actually probably fine. This should be, it said expected an operand, so it should have been here. I'll put in a panic, so it should, yeah, it doesn't ever get hit, which is interesting to say at least. Why is that, is my question. Parse operand. It's going to be a simple statement. So if I look at this thing here, the proc thing should have fallen through. It should have done. So if that is the case, we then, oh no, there we go. We've got expected operands. So if I want to see if we ever get here, and we should, and we do. So I've got a little peek. So in my syntax, I do actually have to look forward a bit more than the current token because of that ambiguity of when you've got nested procedures. And this is actually one of the issues with this sort of syntax, is because you can't distinguish it very easily. So you need to actually have this look ahead, just general peek. Peek's dead cheap anyway, so it's not a problem to do. I don't need any more look aheads than that, but hey, it's not expensive to do a peek. In fact, it's damn cheap. It's not, again, not a problem. And by the way, that one means anything that's not a comment, at least, any other type of string. So then we have that. That's perfectly fine. And then we should go into the fall through. And then we don't want to advance a token. Aha, we don't. That's stupid. There's your bug. We didn't want the advanced token bit. So that is all now working hunky-dory. Hunky-dory. Hopefully people are following along. I'm talking very, very fast tonight. Okay, so that is now parsing correctly. Everything else should be parsing correctly as well. The only things I haven't done yet are the type expressions, so like struct and open things here. So this thing here is a proc type, so return parse proc type. Haha, look at that. Wasn't that simple. Now we need to do the open bracket stuff and the struct, so which is the struct types, of course. Yeah, so one thing I need to do here is parse a struct type, which is relatively simple. So what I'm going to do is write the token, expect. This is just a sanity check for me. This has always been my style, to be honest with you, even though I know it's definitely a struct. I'm going to deal with it. So we have open, open brace, close, close brace. And then you have the fields. And now these are going to have to be parsed differently as well. So I'm going to have, again, because I've got automatic semicolon insertion, things are going to be fine. So the fields are kind of an AST field. We've got a field list, haven't I? So, yeah, I'm going to leave it like that for the time being because I know what I'm doing. So we need to check to see if the current token is an identifier for the time being. That's about it, actually. Yeah, that's about right. That's all I need. So if I'm going to pass a field declaration now, there's all the fields, and then dynamic field, just write the usage code first. That's always the useful thing to do. Struct type to do here, so we've got a new node. AST struct type. We've got a token, and I think we can do this. Whoops, daisy. Pause, open, pause. No, that's going to be token position. And it's going to be the end position of the close token. And what do I have over here? Oops, for the struct type, I have toc and field. I don't even have open and close. So pause. There we go. Toc, open, close, return st, and then fields. Now it's going to be a field list. Ah, now that's why I did it, because I put it in the field list. Aha, I was clever. I thought ahead. Field list. New node, st field list. Again, the position of the field list is going to be open position, and position of the close thing here. We are then going to have the field list. Whoops, daisy. Open dot position. I know some of this seems a little bit redundant what I'm doing. It does make sense, but I'm just adding as much information as I can on there for the time being. Okay, so everything's there. Now it's asking me about parse field decal. I could probably just call it parse field, but st field return nil. Again, most people are asking me, where are you doing your tests? Why aren't you making your tests as you go along? The thing is, I've written so many compilers over the years. I can pretty much just do this blindfolded. It's just the logic's damn simple to write in a recursive descent like parser. It's not actually that kind of complicated. So for a field declaration, I'm going to figure out how this should work. So I think I'm going to do Odin style, which is, and same as it Go style, in fact, is you pretend everything's a list of types first. No, actually, wait, let me think this through. No, it needs to be a list of identifiers followed by a type. I'm not going to support like struct embedding like in Plan 9C or Go yet, because I'm going to use using for that, because I think using is a much better construct than that. But again, there's no real need for it yet, so let's just keep it there. Again, keep the language simple is what I'm trying to state. So a field thing, I've got the names and types. So names, parse ident list, type, parse type, like so. And then what I want to do is then I want to expect if there's a semicolon. Expect semicolon. Now I'm thinking actually, I'm just checking to someone. I think I am going to have to change my code here, especially I've just realized expect token. I need to handle semicolons slightly different. Expect semicolon. And the reason why I just realized that is because I need to check to see if there's any, you can actually just cheat in some cases. So I'm just checking my own logic. If it doesn't equal like a close brace, or it doesn't equal, let's say, a close parenthesis, then we're going to do a partial switch to see what else it could be. And the reason why I'm making a partial switch, you'll see in a minute. It's mainly just for error handling. For semicolon, we're going to advance that token, and it should be fine. For the default case, we're then going to say parse error expected semicolon. And then we're going to advance, no, we're going to do, not advance, we're going to do a synchronization fix, and it's going to be of the statement table. So we're going to skip to the next statement. Nice little error correction already in the parser. Many parsers probably, it's just nice to have error correction straight away. Now the next trick, what I'm going to do here, is for me, because I know I'm going to do it, because I'm used to doing it in I'm just going to do this. Yeah. So I'm going to allow a comma because someone might have just wrote a typo. Because again, in Odin, you have all fields are separated by commas. So just in case I make a mistake, I'm just going to yell at me and say, you expected a semicolon there, mate. So yeah, makes sense. So I'm going to just go in here, expect token. And every time I've got this semicolon, this token here with a semicolon, I'm going to replace it. And that should clean things up now tremendously with the actual code parsing. Again, if anyone's got any questions, please ask. I'm here all night, for however long that is. Oh, and we might be able to actually get onto the semantic checker stage later. And if that's the case, that's fine. I'm doing everything in just one big package for the front end, and then the back end will be a completely different package. And then the compiler will actually just take the front end, the middle end, and the assembler together, smash them, do what they need to do, and then you can deal with it. So I'm doing it in that sense, just for the plain reason is you can treat it as a tools library as well. Like you just check it, we're done. When will this be on GitHub? I could probably just do it by the end of the night, actually. I've not even started a Git repo for myself, like internally at all, yet. So, yeah. Oh, hello, how you doing? I can probably guess who you are, but I won't say your name just in case. So what else did I put in here? Was there any other to-dos? Yes, there was the array types. So an array type I'm going to use again with the Odin style, but I'm not going to support anything special yet. So bear with while I do this. So simple enough. Expect token, bracket, close. What I'm then going to check to see if the current token kind doesn't equal that. If it doesn't equal that, then we're then going to take the len of this expression. St expression, expression length equals 1. And decrease it there. This is just so you have the fixtures. This is the expression level stuff is actually just a fix to get around compound literal issues. So this is the same in Odin actually. It's because I wanted if statements without the parentheses, but compound literals use the brackets, curly braces as well. So you need to get around those issues. And the only way to do that is pass right hand side expression. It's just to actually cheat and have like left hand side and right hand side. So these things are always treated as if the left hand side, which means left hand sides don't like that sort of expression. LM pass type, and we're only allowing type. So this again, this syntax is even more simple. There's no ambiguity between an expression and a type, which is really useful. You can probably pass every single expression as if it was a type. No, every type except if it was expression, but you know what I mean. So, whatever. That made some sense, maybe. Array type. Array type. So we have L bracket. I called it L bracket? Let's call it open. I know what I was doing there. I was just calling them out properly, but no, it's better to say open close. Open equals open dot position. I'm doing a position because we don't want to. That len equals len. Oops, daisy. They haven't got pointers on it. That was easy to fix, clearly. And lm equals lm, and then return. There we go. So type lm. There we go. So we are getting there, by the way. We are nearly there. So pass try type. Do I use it? Oh, yeah. Yeah, I do it in operand here. I was just double checking actually. Yep, that makes sense. So this is a compiler written in Odin for a new language called Midgard, which is designed for WASM. Yes, that is the correct way of explaining it. Again, I'm keeping Odin. I really love Odin. I love Odin for virtually all my general tasks. And again, I probably will just get Odin working in WASM in the future as well. I'll just, again, because we've got LLVM as a backend, we could probably use the custom assembler for WASM if we needed to. It's not that complicated of a thing to write. Again, I just wrote it in Odin. It was 1,000 lines for the entire assembler. It'd be probably about that length in C++. Probably a little bit longer, but not much more. Yeah, and yeah, this is what I'm doing. So the whole point of this is I just want to get around it. So the language is already coming along lovely. I've just been doing some of the weird statements. Pretty much everything is now going to parse correctly. And I'm not even joking, like most things will parse correctly now. So even if statements. So if I go, this will be an invalid. That should work as well. Yeah, that should work. That won't work. You'll say, oh, we expected a semicolon. Yeah, whatever. Perfect. So we can have do if condition. Yeah, that'll work. We can have var x, var r equals true, and then okay. That works. That doesn't work yet. But does that work? Yeah, that works. So that doesn't work, but that's what I was expecting. Expected semicolon, I never got it. So simple statement. I should have got it here. Gendecal. Do I actually express for semicolon yet? No, I don't. So when I pass a simple statement here, like in this statement, I ask for a normal one. If statement If there's an init, I should be waiting for a semicolon, no? But no, I'm looking on line 18. There should be a semicolon on line 18. What? Does WASM get JIT optimized, or do they expect optimized codes? So the short answer is, I actually don't know. I think it's completely up to the web browser to do whatever it needs. So WASM is just a bytecode. It's for the machine. Now, when I first actually saw WASM, I thought it actually looked awful as actually a design. And the more I've been looking at the specification, I've been realizing it's an extremely well-designed bytecode for a thing. It looks like it's a stack-based thing, but it's not. It's not a stack machine at all. It is a register thing, but has a stack-like semantics to it for operands. It is really quite clever what they've done, and they've thought it through very well as well. It's not complete at the moment. It's really annoying. There's certain things like, for instance, they only support one. Oops, sorry, I'm messing around with a slide there from a computer thing. Midgard is not going to be a simple version of Odin. In fact, it's got completely different syntax. It's just going to be a very, very simple thing. So yeah, so WASM isn't stack-based. It's actually quite a register-based thing. It's just it is a bit bizarre in how it looks, but it's actually well designed in what it actually can do. So I'm pretty happy in that regard there. So what is going wrong with this bit here? If var should it be here? So I'm just going to font print line, and I'm just going to print the current token. And it does say var is the correct, and now after that it should say ident. Interesting. So it's passing a simple token, and it looks like it's gobbling up a new line. Oops, which it shouldn't be doing at all. Makes me wonder. It shouldn't be doing that. So if it is doing that, oh, I know what I've done wrong. I've tried to be really clever. So on the value spec stuff, I check for a new line. So expect semicolon. Am I doing that? I know what I've done wrong. So then we're going to, after we've checked the semicolon, we can then do the extra checks. So for the gen decal stuff here, if we don't allow groupings, we don't need to check. Yes, so yeah, import spec. Well, I'm going to completely ignore that. Same with the type spec. We're not doing that as well. We're always going to have a true there, but then everything is now passing is correct. Okay, I didn't take into account the semicolon thing. That was all my fault, but that makes sense. Theoretically, for loops should be fine now. So for I equals 0, I is that, I plus equals 1. Yep, that works correct. That should be passing. That should be passing. And that should be passing. It's okay. Everything is working fine. Yeah, so WASM, yeah, you're right. So from Ben, Business is stating that my understanding of the JIT situation, that it is designed to be very easy and straightforward to JIT. I believe that the intent is for existing JavaScript engines to be able to handle WASM with the same or very order internals, and I think that's true as well. I think I think it's actually a very well-designed thing, would take into account the flaws of the language. So I think, again, it is very well designed. I can't really complain in that regard. So there's that. So let me thinking this through. The one thing I've got an issue with my parser here in a sense is that I like using slices a lot, like array types. But the problem with array types is they do kind of require like a dynamic memory allocation approach. So I may have to actually. Let me think that through. Yeah, I do need that. So I need some sort of free list, to be honest with you. But every single one here is actually a pointer. So technically, as long as all the dynamic arrays, actually, let's just check this. Are every single dynamic array I've got here a pointer? Every single one. Yeah, they are. Then that's perfect. So I've got an idea. I could actually have a completely good allocator for all that system. So I can make the parser work completely with I can make the parser work with two allocators. One is for the nodes and one is for the dynamic arrays. The dynamic arrays will be like a pool, like a pool-based thing, where it's an arena which you can actually do a free list. This thing with like a pool free list, whatever. Thing with the same increments. But yeah. Yeah. So one thing about WASM, I think, is you can actually convert it to pure JavaScript as well, and it will work as you expect. So I think it'll also work as well. So is there anything that facilitates stack allocations in WASM? So in WASM, there is no real stack. So what I mean by that is that they do have something called locals rather than global. So if I just get the WASM documentation, the GitHub one's actually the nicest one to read, to be honest with you. Here it is, make it a little bit bigger for everybody. Go to the instructions. Local get sent here. So these locals are what I would class as local registers. So they are technically allocated on like this own internal stack, but they can only be like an I32, an integer I32, an I64, F32, and F64. They cannot be anything of arbitrary size, which means they are effectively, I would say, a procedure-scoped register rather than anything else, for that matter, which I think is fine. But to actually get a stack-based thing, you have to do the old-fashioned approach, which is effectively create your own stack with some global registers, some globals, which I'm global registers, which then when you're just tracking the heap pointers and stack pointers around and doing it that way. So I'm going to do the old-fashioned approach, which if I get Milton up and running, actually that's from last stream, so it's not a problem. I was just checking there was not notes for anyone else. Whoops, Daisy. Let me get my pen board out. I wasn't planning on this, but hey, we're here now. Okie dokes. So let's go for white. Let's do for this. So for what most people know is they actually might not. Or may already know this already. Let's say you've got some memory, and actually let's just do it big long line here. Here's 0. Here is the possible end, so complete end. So what usually the old-fashioned way of defining things, this is what I'm going to be doing initially, is you define this, and I'm going to call this the heap base. So what this means is you go this way is the heap. This way is the stack. You then have another definition here is this will be, you'll have some different points as well on this line. So I will say the first page I'm going to reserve entirely. So this is reserved. So in pages, so 1p reserved. And then after this is the end. This is the data segment. So this is kind of the general idea I'm going to have. So the data segment is stored after the first page. Everything else will be fine afterwards. So what was I thinking of? That's what I was thinking of actually. I've just thought of a solution, and it's not actually a bad one. So someone was asking me earlier, this is before the stream, is how would we actually like solve different like WASM modules? In a sense, how would you have linking? How would you make a linker in a sense? And the thing is that I didn't want a linker. I wanted kind of like a single compilation unit if possible. But if we did have to have multiple modules, like someone wanted to pre-compile something and you didn't want them reverse engineering what was going on, it's like it's compiled at the end of the day, like a library. I've just thought about of doing it. Now the problem is you can't really pre-compile it. And what I mean by that... Oh, yes you can! Oh, I'm a genius. Genius. Let me just check something before I actually state what I'm thinking. Data section. Data. Mem index, so it's 0. Yes. So I am perfectly correct here, aren't I? Okay. Good news, everybody. Theoretically, this is dead simple. So the way you would actually define this, and I'm going to find it, so let's say you had different WASM modules. This is actually a solution already. I don't know if anyone came up with it earlier, but this is simple. Oops. This is simple and trivial, but to the point where it makes perfect sense. In each module, in each compilation unit, a WASM thing, you need to define a global variable, and this global variable needs to be set externally, or it will have a default value or whatever. So this, in your WASM module, whatever, you're going to have a data segment base variable, whatever, like that. And then this will define what your data stuff is. You'll also have, already defined is segment size. So then when you try and load all these different modules together, automatically, and I mean this automatically, your linker, which will actually just be literally done on the compiler itself, will go, okay, we have multiple different data segments. We now need to order these up so the data segments don't collide. We then want to mix them up and just set the data segment bases for each of them. And then we can actually have them in multiple units. Oh, that's a brilliant solution. Okay, do people understand what I'm saying here? So if you had a WASM module, like you had completely precompiled things and you just want to build them in, each module would have to allow it so people could define a base value for where the thing can be stored. Yeah? So this is the segment base, where the actual data segment will start. But in the actual module itself, it's predefined where the data segment is. Yeah? So it's the size of it. So when you're ordering all the different data segments together from the different modules, you can line them all up, starting from the first page, there's not 0th page, but the first page, because I'll reserve the 0th page for, it's only 64K, but yeah. So this would work with memory offsets, because the memory offsets thing, if you actually look at how it works, that's not the right one. Oops, let's get rid of that crap. You don't want that. That's... Damn it. Did I get rid of it? I got rid of it. Let's just get it up again. What's it called? WASM documentation, that's it. Sorry, got it. I was just getting it back up again. So we go back to the modules. And we go to the data segment here. And what I mean is you've got a memory index, which tells you which memories it belongs to. Effectively, I only ever need one, which is why I only support it at the moment. But I'd like to have multiple just for security reasons, actually. I would only want to change it in certain cases so I could have segmented memory spaces and literally bring back near and far pointers again. But that's a different thing entirely. Oops, not the code section. I want the data section. The expression thing here is any expression you'd like. It's just a list of instructions. So they get evaluated to begin with. So that means you could write anything code you want. You could get a global. This global could be a constant global or a mutable one that could be set from externally. And best of all, that means you can set where the data offset is. And that just tells you what it'll be. Yeah, so mem index. Oh, is that? Oh, wait. Have I cocked that up? Yeah, that sounds correct logic. I think that's correct. I might have cocked up with the spec because it's not that clear. Let me just check to see what I actually wrote in my own assembler, because that's the source of truth that's easier to read. Data section. The first is 0, is the memory index. Yes, it's the memory offset. So yes! Oh, guys, I figured it out. And, yeah. So, guys, I don't know if anyone else has solved this, but that's a bloody lovely way to do it. Thank you, guys at WASM. You were geniuses that actually knew how to deal with stuff and knew how to deal with linkers. That also means you could technically, theoretically randomize it as well. It wouldn't be like really secure randomization, but you like a general randomization, so you can check for bugs and stuff easily. That's really nice. Oh, that's really nice. I wonder if you can actually, in the memories, can you protect certain pages? Oops, sorry. So, JavaScript memory for WASM. WebAssembly memory. Can you protect pages in there? So I'm going on a tangent here, but if I can, so I'm just getting the everything's for you, because you can grow, you can buffer. No memory protection. Oh, the reason why I was saying that is because then I can get null pointer dereference protection. Going to say reserving the first page. 64K, there's nothing going to be hitting that. Ooh. WebAssembly, whoops. Memory page protection. Can we do this? Page, ooh. Is that what I think it is? But I don't think it is, actually. Page size is 64K, isn't it? Yeah, it is. So theoretically, that looks like it's possible. Guys, this is great. Oh, is it in the future? And but can you see where I'm trying to come from, though? Like, I know what I want, but it's like it's not supported yet. It's like, this would be so good. It's like so good, so close. This is the first time I've seen something on the web that's actually nearly done right. Like, nearly, like perfect. It's like, oh, with the compromises taken into account of all the crap in web, of course. But, oh, so close, but no cigar. Oh, that was just so nearly there. Oh, that makes sense. Is this what I think it is? I don't think it is. Yes, no, but it would be. It would. I wish it was. I really wish that was what I was thinking it was. But okay. By the way, I think I have got pretty much a fully working parser now. Thinking about it, just to make sure. Parsing statement is that everything that a statement could be. I actually put a pointer type in there as well. Yeah, put the pointer type in there. And I want, just keep it separate from the operators. Here's a question for this language. Because we can spice things up a little bit, like a little bit here, there, a little bit there. Change little things as we go along. Would we like to consider having the not keyword and like and or? Just to spice things up a little bit. And then you can have like that sort of thing. What would people say to that is my question. Would that be good idea? Just for a change, to be honest with you, because then you would actually have different operations and it'd be a bit clearer. I'm not afraid of actually having loads of keywords in this case, because it's a test language. I want to experiment. Go Python style with the and, nor, and a not, because it allows you to do some other clean things. So to rephrase what you said, to be clear on what you're suggesting for memory, you're saying we can just gather and reorder the data segments from multiple modules in one. I think that's probably possible in theory. I'd have to test it, of course, but that sounds like it's possible, yes. And if that is possible, we have solved linking in WebAssembly. We have literally solved it. And that's, in my opinion, amazing. Like, literally amazing. So I'm pretty happy with that. Again, that's one of the beautiful things about it all. And we could do that runtime really trivially. You'd look through, okay, here's the list of the modules, and you couldn't dynamically load a module. There's the problem. You could. You could dynamically, if you had enough data segments reserved. So if your data, right, because this is the problem you'd have to have. You could theoretically dynamically load modules as well. You'd have to have an allocator to handle that so you wouldn't have like fragmentation, of course, if you were going to deload something. You could actually, you wouldn't, again, I can't think of a case when you'd want to have it dynamically loaded. I don't see any reason for dynamic loaded in this case, because you'd want it all to be statically loaded, or you know what I mean by static in this case. But yeah, that's the idea. This seems like guys, we've solved it. Please remind me, because hopefully I won't forget this. But this seems like I'm pretty happy that works, and it makes sense. So let's go there. So we've got everything else parsing correctly. We've got everything in here. I don't think there's anything else. I'm not sure if I want to handle that. I'm handling it explicitly in case, just for whatever sense. Yeah, I think that's okay. So switch statements as well, I handle. So case 1, 2, 3. And then a blank case, which is the default case. Perfect. Wonderful. Wonderful. Wunderbar. Everything is coming together like there is nothing better in the world. There's no int type, there's only an I size. I don't really care about the names at the moment. Oh, look at that. Look at that beauty. Oh, look at that. Look at that. Right. We can start doing this now, can't we? We can start doing the really, really cool stuff. Okay? We have now literally got to the stage where we can write a checker system. And this is kind of exciting. So this means that on every single AST node, this is why I had a base AST node to begin with. In fact, it's probably on the expressions on the AST expression node here. I can add extra information now. And there's a reason why I did this all in one package, the front end, so because then they can just talk to each other. The back end can be in a separate package, or the middle end, whatever you want to call it, to be optimized and stuff, which is whatever. I don't know technical terminology, but yeah, it makes sense. I'm having an idea that we can probably just get rid of the ands, ors, and not. But we've got not equals. This is the thing, Python has that as well. It's just... I'll just leave it for the time being. It's such a minor thing. I really don't care, actually. Not the word not and not actually does allow for certain things. But not much in the grand scheme of things, really. Yeah. So, yeah. Let's start. Now we've got a parser. This parser seems to work mostly correct. Let's create the new file And I'm going to call this the checker.odin. WASM front end. Yep, I'm calling everything WASM at the moment. I should probably rename it to Midgard. I like the name Midgard. Middle ground, makes sense. Here's the case. So what I'm going to do is kind of copy the Odin style of things. Whoops-a-daisy. There's nothing private there anyway, but it's just clearly I cocked that up. So for the Odin stuff, let me just... I'm going to do the entity systems that are in Odin. I'm just showing you already example. I can write it off my head, but the idea that I have is you have an entity, and it has a lot of information in that entity. So that entity will have different information on it. For instance, the declaration that it's the declaration of the thing itself. So things, for instance, well, the name. That's the most simplest thing you can do. You can have things like the type. So I'm going to put a type here, which is another struct. We'll have things like size and alignment. Oops, bleeding daisy. Yeah, let's keep them small. I don't need to worry about them being big for the time being. I know WASM 64 is not out yet, but even in WASM 64, I'm not going to allow those size of types. Well, I could, but that doesn't make a difference. Let's just not bother for the time being. We do want some scope information as well, so let's have scope, like so. And a scope is pretty interesting as well, so just have elements in a scope, which is going to be a map to a name, so it's a string, and it's a pointer to an entity. Oh, isn't that wonderful? Then you're going to have a parent scope, and then children scope. Just writing out the data structures of what the actual thing I want to describe. Simple enough, isn't it? Parent, elements, children. Simple enough. We can add information to the scope as well. Like, for instance, it may have some like package. So AST package. Or is that actually called AST package? So yeah, it shouldn't be. It should be called package. Like so. There we go. Perfect. Or it could be a file. Like so. Just keeping the things clean, to say the least. And they could probably just be a union as well to keep things tidied, but at the moment it's not making a difference with regards to size, keeping it clear. So we have a scope for this entity. So when you insert it, it will belong to that. Well, not necessarily. I'm going to follow some of the Odin rules, which I found out in the end, which feel wonderful. What package it belongs to. Don't need to worry about any of that. But yes, we've got identifier as well, which I can put next to ident. So that's an AST ident. Could be nil, but not for the moment. And then we have all the other different variants of what we need. Could we have hot code reloading with WASM? The answer is, again, you'd have to. My answer is maybe. Maybe you could. I don't see any reason why you couldn't. So yeah, you'd have to plan it out because you'd have to think what you're doing right. So the variant, and then we've got the different variants here. So we have we'll have an entity constant, variable, type name, procedure. We need to want to say if it's exported or not. Exported name. I'm just putting some information in here just to round it up. What else you got? Procedure. We might have some built-ins, of course. Yeah, we can have a built-in. Library name, let's just keep that for the time being, not yet. We have foreign declarations as well, but foreign declaration is more of a, let's keep it for the time being. Yeah, it's possible to orchestrate it, so you can actually just import modules and keep the memory modules separate from everything else. My only worry is its initial, the data segment, so as long as, if the data segment is all constant, hopefully constant is what I mean, the problem is it would all jump around. So it's a complicated question, actually. So the answer is probably, I don't see any reason why you can't. Like, the model that they've got doesn't have any reason why you couldn't. Again, it's what I'm just suggesting here. Okay, so we've got constants, so we've got a value here. So constant value. We'll say that's a union, so I know there's going to be stuff like this: a bool, an int, float, string. Yeah, that's about it. I think you can probably just disable the data initialization somehow, and even then, it's still a bit janky, to be honest with you. I don't know if there's any different things to worry about. Is exported, is foreign. I'm just going to just do this for the time being. Nothing, again, I'm just writing booleans. We can change them to bit flags later. Variable. Yeah, so variable, we don't need much information there. Like, for instance, field index, yeah, that's fine. And field source index, which they could rearrange, that's absolutely perfectly valid as well. Parameter value should be default value names, so yeah, but I'm not going to do that for the time being. Type name here is, we're going to have nothing yet, so we'll keep that blank. Procedure. Import name, library name, so they are the same. I do have nil as well, which I'm thinking I should probably bring back from, makes sense, doesn't it? Midgard is not an Odin for a WASM compiler. In fact, it's a completely separate language with a completely different syntax and semantics. The whole point of this is I wanted something that was simple. I've written the entire parser already. Like, I've spent probably a total of 5-6 hours on this entire language. So yeah, 6 hours. Plus, no, 7 now, because I'm in the stream, so 7 hours. So not even a day's work yet. And we're already onto the semantic checker. We've already got the assembler written, so the tokenizer is fully UTF-8 compliant. The parse is pretty much done. The semantic checker, I'm just writing out what I need. But in general, it's about that. It's getting there. But yeah, you're right. You could probably remove the data. You need the data segments for, like, for instance, string constants. So I don't know. You have to think about how you do hot reloading. At the moment, I don't think you need to worry, but you probably could do it. Again, I don't see a reason why not, is what I'm saying. And then the library name. So import name. We're going to have a scope here. Path, string, name. A library name, we don't have to have multiple things, so we can have path is string and name is string. Built-in is just going to be the built-in ID, so built-in ID, which we can define later on, by the way. Let's keep it U16 for the time being. Let's call there an invalid in there. And so other things in here, for instance, I'm going to have are like len. Let's actually call it by the names because they won't be keywords. Len cap. Will I need cap yet? No, not yet. Len size of, align of, whoops, offset of, type of. I don't need type of. I don't need type of for what I'm going to do because I think I need to make type of a keyword because it needs to be handled separately. Actually, it needs to be handled completely differently. I think that's probably more than enough for the built-ins. And again, we can have this special nil as well, which has nothing in here. Oops, oh for God's sake, I just tried to type and then it didn't work. So many of these are actually quite blank because I've got no information in them yet. But everything should be... No, I have to do that because they are keywords in Odin for... Whoops. They are keywords in Odin, and I know why they are. It's a different reason, but they are. I think that's fine. I haven't got procedure groups yet in Odin in this language, which I could probably add later, but I don't need it yet. I don't think I'm going to have like anything else. It's going to be such a basic language to begin with, and I can easily extend it to other things if I needed. Which makes sense. Yeah. So that is pretty much that bit done. I'm not going to really have any exported rules or anything like that. We don't need any other flags. Let's call this the link name rather than anything else. Yep, that makes sense. So we now have got different things for the types. Now, I think the thing about a type is, I don't think I should do a union. I don't think. I think I should probably do... I could probably do a union, but it would be appointed to the different types. But let's just keep it for the time being. Like type basic. Like that. Yeah, we could do that. Just thinking this through, yeah. So type basic, it's going to be using a base type. I'm going to do like probably a subtyping here. Just I'm not going to worry too much about anything else. So then with the basic types, type basic kind, and then this is going to be an enum. If we actually look in Odin what the types are, we can do this. So we've got an invalid type, so we have bool, and then all the integer types, i8, i16, i32, i64, isize, and then we have the unsigned versions of these now, which is what I'm going to have. We don't have to worry about Indian specific at all, especially not right now. We have rune, f32, f64, raw pointer, yes. We're going to have a string, yes. And then we need the untyped versions, don't we? Untyped bool. For the type... no, I'm not going to do that yet. Let's keep it simple. Remember, keep it simple. I'm going to have byte, and that's going to be the same as U8 again. It's just going to be an alias. I really like that as an alias. It's so damn useful. I'm going to call this a basic kind rather than a... Oops, daisy. Oh no, we don't have to do that. We can keep it like that because Odin's quite nice with that. So type basic flag. 8 is probably not enough. Let's go 32. Let's go 16. So Boolean, yep. Integer, yep. Unsigned, yep. Float, yep. Pointer, yep. String, yep. Rune, yep. Untyped, yep. Flags, I'm going to make this a distinct bit set. Oh, actually, 1, 2, 3, yeah, that's correct. I do need, no, this can be, that can be U8, but the backing doesn't have to be the same. So, what I mean by that, numeric, integer, float. Anything else I need to worry about in there? Nope. Integer and float is all I have to worry about. Ordered. Integer and float. I also think runes are ordered, aren't they? Pointers and, yes, everything else. So string, pointer, rune, they are all ordered. Ordered numeric. So that's going to be ordered. Hey, look at this. Ordered and numeric. Hey, that's pretty damn cool, right? I love Odin bit sets. They're one of my favorite features. Constant type. They can all be constant, so I'm going to keep it simple. Numeric. So I need to keep it as Boolean. It's pretty much everything, to be honest with you. Does this make all sense to people? Well, hopefully it does. I don't know if you've written an Odin before, but they can all be. Even pointers technically can, but they'd have to be a constant value pointer to make any sense. So we've got the flags, size, again, make it an I32, and then name. One thing I'm going to do here is word size. I'll make it a variable for the time being, but no, make it constant. So word size is actually just 4. And that's what we're going to define it as. So then we can actually put this into a new file somewhere. So types.odin, package WASM frontend, type. We can then do this, and then we can have a massive type table for the basic types, which we can, again, define, which is a big thing here. And then we can go basic types, type basic. Now, one thing I need to do here is the base thing itself. These aren't, they're just cached to begin with. So what I'm going to do here is, oh fuck, you can't do it, can you? So derive makes no sense. It does make sense. Type kind enum invalid basic. kind, type kind. Let's make it an I30. Make it the same as well. Again, keeping it simple. It's probably not the best way of doing things, but we have to probably patch it up later, actually, thinking about it. No, I'll keep the derived, and then we can patch it up later. That's what I'm thinking through about later, if it makes sense. So, everything else can be set. So the kind of this is bool. We have some sets, which is the boolean. And then we also can have the size, which is 1, and the name is bool. So you can actually just go plop like this, and we could actually just go, it's very simple. Isn't that wonderful? We've got the kind. Then we can have everything else. So we have the kind, the sets. In that case, it's a boolean. Size is 1. Name is whatever I wrote here. Len, type basic kind. And actually, it's now going to complain at me because I actually have. It says redeclaration of here in that thing. Yeah, because these are cached actually. There are 17, are there? Invalid as well. Ah, that's why. And they all must be named. Because of course they do need to be named, don't they? Invalid. It was actually a thing I designed properly because it makes sense. So there, that was not very nice actually. That's cleaner. There we go. Look how easy it is to make stuff in Odin. Look how brilliant it actually is. It's like, oh, c'est magnifique is what it is. So now we can go through all the other stuff. So these are all integer. And these are all unsigned. That's rune. Float. Pointer. String. That's going to be 1, 2, 3. And in this size, it's word size. So 1, 2, 3, 4 words. That's not right. That's what we're doing. 1, 2, 4, and 8. 1, 2, 4, and 8. Rune is going to be 4, 4, 8. In my type table, I don't actually take. Do I take into account the alignment anywhere? Do I actually assign the alignment? Basic kind. No, I just say size, don't I? Word size 2 times word size. So then these I can then make kind of aligned. Like so. Look at that. That is lovely. And what we could do is actually put the alignment in there as well while we're here. Just because we can. And it probably just fills it out nicely. Make it well rounded. And in fact, there we go. That was simple. Seriously, that was simple. We now define the alignment, the size, everything. So how is everybody going so far? Is everything making so far? I'm just planning things out. Tables, making the tables. I know what I'm doing. Then we can then populate things with everything else. One thing we can then do with the checker stuff here is we can have dressing mode as well, which again is what I have something in Odin already. So if I go to Parser H. We have different addressing modes in here, so we're not going to copy them all for verbatim, of course. No value, no context variable, we don't need it. Variable, constant, type, built in. That is all we'll ever need. Seriously, that is all we'll ever need. Yeah, that's about it. I seriously think that's about it. What we need to do for the type table stuff. And then we can go back to the AST here, go to the AST expression, and then we can set the information on the expression. So the declaration here, entity, we've got that on there now, haven't we? The expression, we have now got type, mode, addressing, oops, I just can't spell addressing mode. It says type and type. Ooh. I think I know what I need to do. I need to do type and value, actually. Type and value. Type and value is going to have more information. So it's going to have type. It's going to have the value. Is that constant? Would I have a constant value? Yeah. Actually, this shouldn't be in the types bit. It should be in the checker bit. Actually, it should be about here. And then we have the mode. Addressing mode. Technically, this is what an operand is in my compiler, so I could probably call it operand. But no, it's not an operand, it's a part of an operand. There we go. This is, and again, look at how simple an actual compiler is. It's not really difficult to write one. I've fleshed out the actual data structures that I need, and now I can actually start plugging in the code. Any questions? I'm just going to have a literal break for drinks and water. Right. Any questions? We're going on for 90 minutes. I'll probably only carry on for another half an hour at this rate, but hey ho. Okay, is anyone here? All right. I'm going to have the Odin compiler at the side because I can just, it's just going to be a nice little thing so I can don't forget, to be honest with you. Okay. We have the checker, and we have the types. Keep going. Is this enjoyable? This is literally making a compiler from scratch. I understand what I'm doing. Some people say this is weird type unions. I like Odin's because then you can always add extra information. Some people say, isn't this just the same as if I was writing an enum in like Rust and then I had the information in here and did this? And I'm like, it's not the same because this doesn't allow for pattern matching. And I did that on purpose. I don't actually like pattern matching for numerous reasons. It actually complicates things up, but let's not go there. Let's keep this simple. We've got most of this going on. In fact, we can have another built in .odin. And again, the built-in ID stuff can be pushed over to there. Again, Odin's packages are c'est magnifique. So let's keep this going. Keep it going, I keep saying. We've now got the parser. We're now going to go into the different stages of the compiler, which is now called the checker. So we've now got all of this information. What we really want the information now is probably the checker stage. So this is the checker. And this information now has everything in. See, have a good night anyway, Sherlock. So the checker is going to have the information in it. So we'll have the, I'm going to say the packages in there. Okay, so we have the packages in there. Now the next style that I'm going to do is I can change it. So the whole point of this compiler says it's going to be a simple thing, but the entire language is going to be, the entire compiler, I'm designing it so that it is possible to multi-thread the entire thing. So that's the design of it. This is something that probably some people didn't hear there, but I'm going to multi-thread the entire compiler. So what that means is that the parser stage, each file is tokenized, is parsed separately in a thread. When you get to the checker, you collect all the global entities, and then the procedure bodies are checked individually, because the procedure bodies are all going to be well defined. So then you're just going to add, when there's queue, you keep adding to that queue when necessary, but the entire thing is just a work queue and be done. So procs to check. This won't be, it'll be something else there later. So this would be a proc info. And stuff like that. We're going to also want a checker context that you're wanting to checker context, which is here, like so. We also probably want the checker info while we're doing things. So there is the info. Now, actually, do we need a checker info? The checker info is what I used in Odin for a big type table. I'm thinking about it. I don't think I actually need anything yet, except maybe a big array of the entities. So if that's the case, we can have entities. We can just do this. Entity. Trying to think of anything else I'd need yet. Yet is what I'm trying to state. I'll need some other. We'll want a built-in package. You'll want the init package, or the init scope at least. Yeah, I'm just thinking this through. That's about it, to be honest with you. We'll want some other things maybe as well. Like, for instance, files. We'll want a big map for that. Like so. We'll also want packages. And they'll also want foreigns as well, because you don't want to overly do it. Let's call it foreigns. It's another map. In this case, it's just a string map. And then we got an entity in there. And again, each of them just going to be defined. Is that? I've already defined packages. Yeah, I have. Yeah, to be honest with you, at the time being, I don't need any of that crap. So now I've got proc info, and I haven't even defined any of that yet. I'm just thinking this through as I go along. I'll also need decal info, so the information about the declaration. Proc info is just information about the proc I'm doing, so each thing will have a file associated with it. It'll have a declaration, which is the declaration info. It'll have the type. It'll have a body, AST statement, which is actually, no, it's a block statement, isn't it? That's about it. For your declaration information, you may have some parent in there. You're going to have a scope, the actual entity that you are dealing with. So let's put that there. Again, the entity and the scope may have completely different things, so let's just be very careful with that. We want some other information when we're actually doing the declaration info, so you'll be wanting like a type expression. You'll also want the init expression stored in there. If it's a proc literal. You may also want the dependencies, which would be, again, pretty useful actually. And that sounds about it to me. Yeah, that's about it. That's depths for dependencies. Everything's compiling as I expect. Again, everything is going smoothly at the moment. The thing here, the scope, is that, well, I'm just looking at the scope, sorry, it's down here. The children, I don't really like having dynamic arrays everywhere if I actually don't need them. So what I'm going to do here is I'm going to do previous and next, first child, last child, and then we've got the elements, so we can keep the pointers together. The map for the elements here, if that makes any, oops, daisy, I keep clicking crap. Okay, dokes. So this is where things are going to go fun. Fun. Oh, it's very, very fun. You heard that correctly. Fun. And I'm just going to do operand while I'm doing it TAV, so using type and value, expression, which is an AST expression, and then built in ID, so that's a built-in ID. Oops, I keep hitting the wrong key. That's what happens when you're a bit tired. I think this building's still fine, there's nothing really going wrong. Is everything making sense so far to everybody? Yeah, good. I don't really see any other like big issues with any of this yet. Yeah, don't worry. The WASM docs aren't that. I find the GitHub one's better than the PDF, but yeah. Yeah, you can see, again, I'll get this thing up public so everyone people can just start doing stuff to this. Because it's pretty cool. I will have to admit that. It is pretty damn cool. So... It's going to be fun figuring this out. Oops. Like so. Type. Slice. I'm just going through all the stuff. Type struct. Fields. Entity variable. That's about it, to be honest with you. There's not actually much else to add to that. Pointer type, yeah, that should be type pointer, which is technically the same as a slice internally, you know, like the same data structure. So it's the base type, it's the element type, same thing. What I'd also add is tuples, which is the way I handle things internally in Odin for stuff. Let's call it vars on variables. It's just easy to write. Type proc, which is technically a signature. So we could call this type signature, but I like type proc, would be easier. So each thing is going to have its own scope. So we have to have its own scope for the different things. It's going to have the params, which is a type tuple. Results. I haven't supported variadic stuff yet, so let's just keep it blank. It'll just remind me in the future. Is that all the data types that I need? Just to come to... No, there's named. Named. I nearly forgot. So the named stuff is going to have the entity in it. Entity. It's also going to have the original type that it originally points to. No, underlying type is a better name, not original, underlying. Anything else I need to think about? Any other data types? But that seems to be enough that I can think of. That makes the most sense. Yeah, I can't think of anything else. I think, come to think about it, I need to check for when you're doing cycles, because you need to do cycle checking. So type named state. We're going to have marked, valid, and invalid. Oh no, unknown as well. I think invalid should go before there. So marked means you're processing. Processing makes more sense actually, not marked. Processing, cleaner. So I'm checking for like type cycles. So what I mean by that is that, for instance, if you're doing type, this is in this language, in the new language, and you did an array of 1,000, I don't know, make a number up, that would fail. Like that would be like, oh, that's a type thing. Even if you did an alias, that wouldn't allow. So they wouldn't allow for the type cycles. Is what I'm trying to state. Yeah, that makes sense. Yeah, that makes perfect sense. But now I need to think, looking back at my Odin code, I'm looking at what else I need in the checker context. Because I've got operand here, and we've got the checker stuff which is containing some of the info. For instance, yeah, we'll just keep it like that. The context, we need to take into account what stuff we've got in there, like for instance, which package we're in, which file we're in, which scope we're in, if there's any current declaration we're in. Yeah, not decal info, just say decal, keep it cleaner, much cleaner. We can say what current proc name we're actually in. So we can even have current proc decal, if that's the case, because you could have multiple declarations that you're within. The current proc type proc, again, keeping it very simple. We could have all of the different... a type path checker as well. So... so type path checker eventually is technically just... type path is again, it is effectively this. There's nothing special about it. You just keep pending and you're just doing it that way, and it's perfectly fine. And everything else, this should be, again, I don't see anything that's special about this being untype safe, to be honest with you. Maybe you should have that as using as well. That's fine. I don't need anything else on that list. So now we can first get to the first stage, which is checking and collecting the entities. So now we've got the checkered things, and then we're going to check decals. Oh, now this is the annoying thing, because it's like, what do you call the first file where you come into things? I want to make it easy so everyone else can use it, of course. Again, I just called it checker. But effectively, yeah, I could just do it here and just call it that and move the other stuff out of the way later. I'm just trying to think, is that all you need for the context? File, the package file, the scope, yeah, it makes sense. The declaration, yeah. This decal thing, I know. I think I prefer decal info again. Sorry, I getting the names correct. That's all I'm looking for. Very clear. Again, it's being clear about the name, just to prove that it's getting correct. Yeah, it's being parsed correctly. Can anybody? Is that all I need? Okay, so I think that's absolutely fine, come to think of it now. So checker, like so. We want to then also start the thing. So we haven't actually set up a package yet. Package. What is in a package? We got an ID. Go back to the main file here. ID we're going to call 1. Name we're just going to call this main. Full path we're just going to call as WASM/source. for the time being. Actually, let's call this under let's put it under Midgard actually, and put the test file in that package. So then we can call it Midgard. Midgard. And then files. There's only one file in that list. Oh, is it already? It's already a pointer, so that's even better. So now I'm going to check the packages. So we've got the package. There is no check package, but we do have a checker. Aha, see what you've seen going? We'll write the usage code first. It's very useful to have. So check packages. Package. That's fine. And we're going back to main. And we need to put the checker in there. Checker. And what I like to do is just have checker. So for each package, we're then going to create a scope for each package. I'm going to create a scope for each file as well. And then they're all correctly created. Yeah. Let's call it create scope or new scope? New scope. Parent scope. Scope. New scope. To be honest with you, it can be just a new clone of a scope that takes in a parent. And that's literally all the new scope needs to do. So if you look at what a scope does, there's nothing really special about it. So for each their packages, so each package in packages, we're going to go here. We need to make sure they're pointers as well. Keeping it simple. Each package. It's going to have a new scope to it. No parent. But each thing is going to have a package associated with it. There we go. Makes sense. Let's keep that over there. And look at the scope we have defined over here. No elements, nothing. And then in each files, we then have file scope. File scope package is the same as the package. Package scope is the parent. Return S. If parent doesn't equal nil, we're now going to add children to it. Okay? And if I can remember, people are going to laugh at me. This is not how you're supposed to do anything like this. You should do it correctly. Yeah, what I mean is, it's not like... When I'm creating a scope, let's not call it new scope, let's call it create scope, because it is cleaner that way. We set the parent in there, and then we can set everything else up as well. For instance, if the parent scope doesn't have everything, and the parent doesn't equal... no, then the parent's fine. We got a parent first. What we want to do is I'm going to create a little... I know what the macro is effectively in my little code, but it's more of a... You need to handle it correctly, so I'm just going to do it here. So first child equals nil. then what I'm doing is first child equals s, if you know what I mean, and then we also set this to be the last child. Yeah, makes sense. Else we're now going to set everything correctly. So the last child is now going to be set as that element. The previous is going to be, the previous child is whatever the current element is, so that will be is that correct? Wait, this should be obvious to me. I'm just getting tired. Wait. Yes. Yeah, no, that's correct. I'm doing it correctly. And then the previous child. No, that's what I need to do. So the next one in the previous thing, and then you reset it. No. And then next. Not parent. Is it parent? Parent of the last child is the next, and it gives you the... Yeah, that's correct. Yep, that is absolutely correct. I just couldn't think about what the logic was then. Package has no field name scope. Well, it's going to soon. Scope, and everything else has that on there as well. And look how lovely that was to create a scope for everything in there. And then we can now go and do the insert scope stuff as well. Yeah? Or scope insert. Yeah? So we can have different things. So scope insert. And then we've got the entity. And then what else I can do with name, which sounds like, why am I doing that? It's just because the top one is more common than the actual, what you'll explain. It makes sense when I'm going to do it. And each one of them will return an entity if it's previously found, is what I'm going to do here. So that's the rules that I'm going to be doing, if that makes any sense. So if the name is blank, then return nil. I'm just going to state if if entity is in elements. Oh no, I need found. Previous. Oh no, let's say found. No, I already, again, scope elements entity. If found doesn't equal nil, return found. Yeah, that makes perfect sense. So then we're going to go kind of checking. No, that should be fine. So S elements I entity. No, it's the key is the name. Whoops. Name entity. If the scope of entity equals nil, then we're going to set the scope of that entity, and then we're going to return nil. Like so. That's making sense already. So now we can do that. Again, this seems like I'm doing a load of crap so far. I'm not doing anything useful. But again, I'm just creating the information for the checker. So the init scope is going to be whatever the first package scope and first file is, effectively. this is a bit of a hack. To do Bill. Fix this logic. For the time being, it's absolutely... the init scope is actually going to be the package scope, actually, just not the... It's going to be whatever the first package is. That makes more sense, to be honest with you. And then what we're going to do now is collect the entities. Simple enough. We're going to do the same logic again. And now we've got a package and everything. And now we're going to create our own little context for each of it, which is going to pass the word C every time. It's going to be reusing every time, but it's context. So checker context. So checker checker. And we probably want to destroy a checker context as we're going along. Probably. And then we're going to do for file in package files. We've already created a scope for each file as we've gone along. We have some, I'm just looking at the checker. There's no other information that we need to worry about now, is there? So then we can say for each context, we can set what the file is. We can set the package. Again, let's look at the context thing here. We can set the scope. Now the scope, is going to be the file scope. There's a reason for that, but it's going to be inserted in its package scope, so it's actually a little bit slightly different. Scope kind enum normal package file type. So when we're creating all the packages stuff here, we can just set this its file get it a bit recursive, but yeah, that's perfectly fine. We haven't got a file there yet, we got a package, but now we're going to go do this, and then what we can do is collect entities, pass that context in, and then we can pass all of the file decals in our code. So collect entities, check a context, notice we've done the C thing now, and then decals, AST decal. Now the problem with the AST decal thing here is that it probably doesn't make any sense to do that there. But yeah, you kind of do want the collect entities approach. So now you're going to go through for each decal and decals. You kind of want to go through them all like so. Make sure it is a declaration, of course, can't be anything else. We're now going to just switch on that. So D in decal, derived. Luckily it doesn't have anything else specified, so we have AST bad decal. We're going to have what other decal types have we? We haven't got that many. We've got generic one, proc one. Yep, that's it. Just to prove it, we haven't got anything imported in this package, of course, so we can now just do core funct, just so things can get cleaned up. Okay, we've got a load of crap in there. which is fine, actually. That is kind of what I wanted. Just to prove what's in there, proc decal, we also got a name in the proc decal, name.name, toc.text. Oh, look at that. Oh, yes. Isn't that fan-dabby-doozy? Like, look at that, how good that is. We're already going through it all, guys, and we're already collecting all the entities. So when we collect an entity, we create all of the different things. So we want to generalize this code in a sense. It's not really, but we want to. We've got all the different things in here actually. So we needed a case here. So I'm just thinking we need to put an error call in here. This is one of the first things we actually need to do. And for the error, we want a position, we want the message, and then the args, of course. A global error count. The global error count will be atomics, intrinsics, error. Again, I want the nice same format. Tokenizer, that takes in another error handler. Oh, isn't this wonderful? We have now got a built-in error handler already. Who'd have guessed? Checker. We can put the checker in rather than a checker context. But it's the checker context you want. It's the same thing. And you want to put all of that. No, we don't. So the checker context error. Like so. Yeah, actually that makes more sense what I'm doing. Actually, we don't even need that because we're doing it on the checker, so it's all correct, isn't it? So, when we then go to the main and create the checker, default error handler, we now have something we can do seek.earn, it's working. It looks like a method. It's like a method, in fact, but it's not. It's just a cleverness. We could technically make it a method, but we're not going to. That's stupid. I just want to get to the basic checking of the declarations first, and then we're going to call this a night, because, to be honest with you, this has gone pretty damn far, to be honest with you. This is actually pretty cool. But when the declaration checking, you have to check for cycles, so you want to make sure everything is kind of handled out correctly, in a sense. Yeah. So we got all of that. I'm just thinking this through. But we're doing all the stuff. We want to collect all of the entities at the declaration stage. We're going to do this. So we go through this stage. Shall we just do the basic ones first? So let's ignore that. Let's make it cleaner. Like so. We could probably put in a default one here. Deposition, invalid AST, unknown AST decal. And we've got %t. So let's just do the new fashion stuff like so. Not error, it's isn't it? Decal position does have that. So let's do decal position. But what then we can do through is go through every single declaration and go through it the generic way, which is what I've got here, which is why I did it for that. For spec in specs, switch on the spec derived, and then there's only a few different specs we can do. There's an import spec. If I look at it here, I don't know why I did import spec first, but because it's no, it's first. Yeah, I was right. Value spec, type spec, foreign spec. Now I haven't done an export yet, but that'll be an export declaration. It won't be an export spec. Well, yeah, actually, could do an export spec. No, export spec doesn't really make much sense yet. So let's do that. Let's just do variables just to keep it simple. Values at least. We can then just do s dot value spec. I've just realised I've got a bug in my parser, which is makes it absolutely useful. Not token value spec. I've got a keyword. I never use it. Literally, I never use the keyword. Spec, it does have a keyword. Oh, it's yeah, let's call it keyword actually. Actually, yeah, let's call it keyword because it makes a little bit more sense. Hey, that was easy to fix, wasn't it? Spec keyword kind partial, of course. Case const and var. There's only two. Doing it in alphabetical order. Let's start with const because the logic behind a const is probably the most simplest. We could probably do sanity check as well and just say invalid AST unknown. No, invalid token. D. Oh, no, it's D there. So s dot keyword kind. Like so. Let's do the constant one first because it is probably the simplest. So for name in names, and we probably want that, don't we? I'm just going to do a basic print of all of the names, and yeah, we want name.name to be honest with you. We don't just want the identifier. Oh, look at that! Look at that! Look how good that is! Really good, really good. We're getting there. We're going to get there. So we're nearly there to get some basic stuff. We can probably create a new constant integer thingamabob. You know, nonsense. So that's just one thing I actually just remembered for the entity type. We can actually put the position in there as well. Like that's really kind of useful. You can put it in the identifier, but not everything will have that. And go for every single name. And each name will have a type. So S type, is that correct? Yep, look. And then values. So you kind of want to check if the values are correct. So that's why what I was doing here is if I was less than the length of the values, yeah, I was checking ahead. Then we know that this is valid and it won't cause an error. But then we need to do an arity match on the actual thing. So we need to do that. And no, I'm just leaving that for the time being. I'm just trying to think because they are both the same technically. So like var is going to be a lot more complicated because you're going to have to evaluate the expression later. And in your declaration information, you're going to have to give it the type and the initialization thing later. Yeah, does that make sense? Oh, I'm just too tired. I think I need to go to sleep, is what I'm saying. So thank you all for watching. I will put this on GitHub probably tomorrow for everybody. We're going to proper thing. On a proper repo so people can just see what's going on. And when this gets to a decent stage, people can help out. It's just a little language. I'm trying to keep this very, very small. Do I have... yeah, I do. I do have lines of code. I'm just checking how much lines of code in Odin there are. I cannot remember. Right, how does anyone know how you do count of lines of code and then do it for custom language? Because I just want it to count the lines of code for Odin. I can't remember how to do it. That's how much tired I am. But essentially, this is a right to file the binary data and be done with it. So assemble. This is still kind of the compiler bit. But yeah, the general thing is pretty simple. This was my basic example with the assemble, and it's pretty simple. But like the entire compiler, to be honest with you, let's just do it. Let's just look at it. The AST. I'm going to write this down on paper. How big this is. So we have 3, 5, 4. Ignoring the printer for the time being. 11. 2, 5, 6. Oh, what a lovely number. Parser. Parser is 1,582. This is a rough estimate, of course. 271. Tokenizer. 598. Types. I've still not used it all, by the way, but it's still pretty damn small for a compiler. And then this entire thing as well, let's just say that's... I don't need it all, technically, but let's just say it's 200. Just put 200 on the end. We're going to say 225, yes, put it correct. And let's add all those numbers up. Ah. You need to read a definition file. Thank you for that. I'll do it. I'll do it in a minute. Thank you. So we're going to go 4. So I'm just counting up in numbers. So that's 10, 13, 14, 22, 30, 35, 11, 19, 26, 20, 35, 38, 40, 43, 5, 10, 12, 17, 17, 18, 20, 24. So we've already got about 2,000 lines of code, 2,435 I've counted. That is not bad at all. I mean that. There's the Odin lines of code. Thank you very, very much. I think I got rid of the command line. I was very smart. Not. WASM. WASM. So I can now just do count lines of code. Read lang def Odin in the source file, 4,000 lines it's saying. Now I don't trust that because I've got the printer, so I'm going to ignore the printer for the time being, and there's a big reason about that because I didn't particularly like my printer. Yeah, 3,892. That is surprising. How did I count that wrong? Yeah, I counted that wrong, didn't I? Yep. I can't count. But anyway, that's not bad, actually. That's surprisingly not bad. It's got 10 files. Oh, I've got the assembler I didn't count. No wonder I was like a bit off. So the assembler, let's count that. So we got 1,000. There we go. I was thinking, my math isn't that bad. And the disassembler, yeah, that was just for debugging. I didn't need that yet. It's not complete. So adding my numbers up together, I get 3,496, 3,759. Close enough. Seriously close enough. I am pretty happy with that as a little language so far. I hope people have actually enjoyed this stream tonight. If you have any more questions before I go, or any ideas about this language in general, what is the whole point of being Viking writing another language? What the hell am I doing? So yeah, it's just a little project, hobby project to me, just to get away from Odin for a little bit. Even if I only work for this for a little tiny bit, I just wanted to see if something was possible. Like for instance, look, I can literally already in my assembler pass in things. You can call your own thing, text and stuff, and it works. Like just to prove that this thing works. Let's load. Oh, what am I looking for? Open in browser, default. Hey, look, like this. That has been ran from my assembly. I am not joking. To prove it is written from my assembler, for you guys out there who don't believe that. I don't know why you wouldn't believe that. But yeah, so let's say hello to YouTube Live. Does that actually get called assemble anymore? No, I don't get that called anymore. Assemble. Whoops. There you go. Look at that. Look at that. Look at that. So yeah, that was just to prove it. This is all working correctly. And then we also do a lot of other, in the main function we do all this. So like for instance, we can change the position of this. That was probably not a very good place to put it. Was put it there. Look at that. Change the radius. Let's make it tiny. Or we can make it huge. We could change the amount of the arc radius that we want to do. So we can actually start only half of it. There we go, half of it. And remember, it's because Y is down, so it is positive rotation. It is doing a positive rotation, but it's Y downwards. So positive rotation is the opposite way than you think. Because normally it's counterclockwise for positive. Because Y is down, that means that clockwise is now positive. So it goes from that point across. Yeah, it's a little bit confusing, but it makes sense. Kind of. Let's see if that works. No, it's no different. But that was kind of good. And look, the text, and we can position the text elsewhere. I'm like, look, we have clearly... I liked where I had it originally, so I won't change it. We've got things working. And that's fine. So yeah, this is what I was talking about, the heap base and the data end and where all that stuff was originally. And then this is also me how I was actually going to experiment with different pointers. So you've got a stack pointer and a base pointer and stuff. So you've got the RSP, and I could probably call them better things, but that was the idea I had for the assembler. You could pretty much do whatever the hell you want. So thank you all for listening. This has been going for 2.5 hours now. I should have gone to sleep about half an hour ago. So thank you for watching, and today we started on Odin's Day and now it's Thor's Day, so Odin's Son's Day instead. So thank you for watching and good night.